Hi everyone. So this is the fourth video in the Stacks and Queues series, and in this video I'm going to talk about how to implement a stack using an array. Now, so the way that you would implement a stack using an array begins with basically an empty class that looks almost the same as the linked list version, but there are a few subtle differences. So first of all, in the linked list version, what you will notice is that there is no argument to the constructor, whereas in the array version, right here, there is an argument, but the argument does have a default value. Now, the default, this particular argument lets the user suggest how much data they plan to put into the stack. And that way, you can specify the right size array right away, which will avoid having to avoid having a grow function be called on it. Now, your program shouldn't crash if the user guessed wrong and you have to grow. So you should be able to handle it by having a grow function. Um, but it's a good idea to have a way for the user to suggest how to begin. Okay, so this is pretty typical. So this is what we're going to have. We're simply going to create a stack with a initial capacity of 4, and then it will grow as needed. The stack has push and pop function. Push pop top is empty, just like the linked list implementation. This part is not different. And it also has a destructor. Now, we didn't need one over here because this is just a data member. And so when the stack object goes out of scope, this object will go out of scope and its destructor will be called and it will get cleaned up. So I don't need to explicitly deallocate this because it's not a pointer to a linked list. It's just a linked list itself. This is why I didn't need a destructor here. Over here, because we're going to dynamically allocate our array, we actually need a destructor to get rid of that array. So that's pretty much what it comes down to. Now, let's take a look at how this would work. Like, let's take a look at how we would actually code this and what the implications are and so on. So in order for us to program the stack, we need an array data structure. And because we don't want our array to ever run out of space, we're going to have to dynamically allocate it and have a grow function that will grow it. So here we go. T star the stack. So the stack in this case will be an array. Now, whenever you have an array, you have to have two other variables that goes with it. Remember that this is the whole idea of capacity, which is how many elements does your array have initially, versus how many elements of that array is currently being used. So we have capacity and use. Remember, this was the glass. The glass is like 300 milliliters, and there's like some water in it, and this is how much is being used, whereas this whole thing is that's capacity. So capacity is the whole glass. Used is how much liquid is inside the glass. That's the way to sort of think about it. You have to have both because they're not the same values. So here we go. So we start off like this. The stack is initially created as an array of type T with capacity number of elements, or cap number of elements. Capacity is, of course, equal to cap, and used at the moment is equal to 0. Now, when we talked about lists, we also talked about how to put values into a list quickly. Like what can we do to place values into a list quickly? And in fact, we're going to basically be doing that in our stack. So what we do to put values in, let's imagine what we're doing. Okay, so this array is an array that we created using the default constructor. Now, according to the default constructor, our initial capacity, which I will short form to cap here, is 4, and our used initially is equal to 0. The index for this array, of course, is 0, 1, 2, 3. Now, imagine what would happen if I had done the following: push 5, push 9, push 1. Imagine that those are the three numbers that I added to my stack. Now, remember what this is, if we were to think of it pictorially. 5 is the first item that I add, then I put in the 9, then I put in the 1, right? Like that's what I would actually be thinking about if I was thinking of it like a stack. And at the moment, this would be the top of the stack. If I were to do a pop, the one that I would remove is I would remove the 1. And we want to be able to do this quickly. Now, this is really important. Being able to do this quickly is the key. So over here, if we were to do a push, okay, what would happen? Okay, so uh, push. So if we were to do a push, where would we put it? Now, we talked about this when we talked about an array. One of the things that we can do if we were putting something in is we can simply put it in wherever used says to put it in. So in other words, when I do a push, what I do is I simply say, okay, let's make sure that it's big enough. This is actually one of the first things you do. If if used is less than capacity, so in other words, if I still have, if the number of things that I want to put in, that is in the array is less than how much room I have, then I can just put it in. Now, if it is equivalent or greater than or equivalent, it should never be greater than. If it's equivalent to capacity, then what I have to do before I can do anything is I have to actually grow the array. So I'm going to call the grow function, which will magically make my array twice as big. Now, we already talked about why it has to be twice as big, okay? In previous lecture, when we started talking about lists, when we talked about list implementation, we said we have to make it twice as big. Remember, because if you make it twice as big, you amortize the cost of the grow function over all of the push functions that you're going to do. And if you don't make it twice as big, then it costs too much. Okay, so whenever you grow, remember that you have to grow array by twice, grow array to be twice as big. That's what the grow function has to do. Okay, we'll come back to the grow function in a bit. But effectively, we start by simply saying, hey, if you're full, make a bigger array. Now, once we get past this if statement, either we had space to begin with or array has been grown so that there's space. So at this point, whether or not there's space is already taken care of. There's space. So where do we put our data? Well, it's actually pretty straightforward. We simply take the data and we put it where used is. Used is equal to data. That's it. Now, at this point, I now have used one more spot, so I have to increment used by 1. That's all we have to do for push. So how would that work pictorially? So imagine, so this is the idea. What would happen when I did these 3 functions? So when I push 5, my 5 would go into here. My array is big enough, so I simply increment the used to 1. When I push 9, it's big enough, so I take the data, put it where use says, which is at 1. And then when I push 1, my again is big enough, so I put it where used is. Oh, sorry. When I added 9, it's now 2 items are in it, so used is 2. When I add the 1, it goes into the wherever use says, and then I increment use to being 3. That's it. Okay. So this is my stack. This is the equivalent. Now, keep in mind that this is where the top of the stack is. Okay, so this is the top of the stack. This is the top item in the stack. Okay. Now, let's start by writing top instead of pop first. How do I get to that item? Well, remember that the number of things that are in here is stored by used, and the most recently added one is at the back of the array. So all I have to do here is return the stack sub used minus 1. Do not use use minus minus. That would actually make it smaller. Okay, use minus 1 and use minus minus are not the same thing. So if I take use minus 1, I would return, this would give me 2, which is where the most recent item is. If I do use minus minus, I would alter the list. I would basically erase. I would be doing a pop. So don't, this is -1. This has to be -1. What about pop? Well, the pop function uh, basically says, well, let's make sure that let's remove the most recently added item. How do I do it? Now, you don't have to actually remove something with an array. You simply have to say that that item is not part of the consideration. In other words, it's not one of the things that we actually care about. So when you create an array, no one actually says what's inside that array. You actually don't know what's in it. So the fact that you have a used value initially of 0 indicates that none of the cells should be looked at. Like you shouldn't be taking a look at what the value is because you don't know what the value is. So when I do a pop, the only thing that I have to actually do is decrement used. Okay. Make sure that there is something to pop first though. So if not is empty, make sure it's not empty, and then used minus minus. That's pretty much all you have to say. So as long as the list isn't empty, decrement used. You don't have to actually remove an item. You don't have to delete an item. You simply have to say that item there. Just ignore what's there. That's not useful anymore. That's it. Okay. Now, what do we do next? What about is empty? Okay. What does is empty do? Is empty just simply says, is the list empty or not? So or is the stack empty or not? Well, how do I know? What is the value of used? Return used equivalent to 0. If used is 0, it's empty. If it's not 0, it's not empty. It's actually as simple as that. And then finally, the destructor. Well, it's an array, and when it goes out of scope, I have to make sure the array is deallocated. So this is your standard delete square bracket, the stack, and that pretty much covers it except for the grow function. So as you can see, this is how we would implement it. It's not a lot more complicated than the linked list, but it does involve making sure that the array is properly created and so on, and making sure that it's deallocated at the end. That's pretty much it. So grow function. This is the same grow function that we had when we talked about lists earlier. So as a quick review, how we do grow is we start by creating a new temporary array that is going to be twice as big as the old one. So this would be capacity times 2. Then we take the old one and we copy it in. For int I is equal to 0, I less than capacity I plus plus. You can also use used here instead of capacity, but the reason that you would call grow would probably because it's used. Now, if you want to make it more versatile, I would argue that you should probably actually use used here, because this would allow you to call the grow function before it reaches capacity. So I would use use. Use is more accurate, more correct. But the way that it's written right now, it would the only time we do it is here. So, but this makes it more flexible in case you want to expand your stack for whatever reason. I don't know. So the stack temp sub I is equal to the stack sub I. That's it. And then temp delete the stack. Don't forget to do that, because you have to deallocate the old list, otherwise you have a memory leak. And then make the pointer point to temp. Do not delete temp, because temp is a pointer to the new array that you just made bigger and copied everything over into. If you delete temp, you don't get rid of the pointer, you get rid of the new array. So really important idea. This is all you need to do. Make sure that the capacity is properly updated, is equal to capacity times 2. Make sure this is done. And that is all you will need to do to grow your array. You make it twice as big as before. So that's pretty much the array stack implementation. Now, I don't guarantee that this is, there may be a syntax error in here, but it will be just a syntax error. I think this is correct. So in any case, that's it. The next video is in how to implement a queue using an array.